going on? Good, excellent, wow, good. So today we are going to start a very interesting topic which comes under motion in a straight line, and that topic is motion under gravity. Okay, so be ready everyone. Today we will learn this topic properly and we will solve a lot of problems, a lot of interesting problems which comes in different examinations under this topic. So let us start without any delay. Everyone take your books, take your pen and copy and be ready for learning this topic. So today, what is the goal? Our goal is, first we will learn what is gravity, equations of motion under gravity, some important calculations and results and the problems. Okay? Now, what is gravity? So we know that there is always attractive force between two masses. If there are two masses in universe, there is a force of attraction, and that force is called gravitational force. So in the same case, our earth is also attracts any object to each and every object towards itself. And this gravitational force, the gravitational force of earth, the gravitational force, the gravitational force of earth towards itself is called gravity. Is called gravity. Is called gravity. Okay. So if you are talking generally two objects, then the force gravitational force. But when one object is earth, then that force is special. It is given a special name, that is called gravity. So what happens? Actually, when we learn about the Newton's third law, we see that there is action and reaction. If one object attracts to another object, then another object also the first object. In the same way, when earth is there, suppose this is our earth, and any object is placed here. Any object is placed here. The mass of earth, suppose this is capital M, and suppose this mass is M and this radius, so this is the radius is R. Radius is R. And if this mass of the object is M, then there will be a force on the object, and that force is gravitational force F. And this F is given by G capital M small m by R square, where G is universal constant. Its value is given by G is equal to 6.67 into 10 to the power minus 11 Newton. Okay, Newton meter square upon kg square. Clear? So this is the force acting on the object by the earth. Okay, and we know that the mass of earth is very large. What is the mass? Mass of earth is nearly 6.0 into 10 to the power 24 kg, and radius of earth is nearly equal to 6,400 kilometers. And if any object is there on the surface of earth, so this earth is applying force on the object F this much, but in against this force, this object is also attracting the earth to itself. It is also attracting the earth to itself, and this amount of force is same. जितने फोर्स से ऑब्जेक्ट जितने फोर्स से अर्थ मास को अपनी ऑब्जेक्ट को खींच रही है, उतने ही मास, उतने ही फोर्स से वह ऑब्जेक्ट भी अर्थ को अपनी खींचता है। ओके, so what happens now using Newton's second law, this object will be accelerated. This object will be accelerated, but this earth is not accelerated. Why? Because its mass is small. Mass is small. So acceleration is equal to k is equal to f by m. So mass is small, therefore there will be acceleration. This object start accelerating. Okay, 1 minute please. Yes. Okay, so this small mass start accelerating due to the force, but earth do not accelerate because it has a huge mass, and due to huge mass the acceleration in earth will be f upon capital M, and this capital M is of the order of 10 to the power 24, so it will be negligible. That's why when we leave any plane, it's fall down now, it is falling towards the earth, but earth is not moving upwards because its mass is very large. So this acceleration is called acceleration due to gravity. This acceleration is called acceleration due to gravity. Okay, and this is small. This is noted by small. So now have the conclusion means if any mass is there in the gravitational force of earth, earth is attracted to that mass, and due to that force of attraction the mass get accelerated, and that acceleration is called acceleration due to gravity. That acceleration is called acceleration due to gravity. Acceleration due to gravity. Acceleration due to gravity, and it is denoted by small g. It is denoted by small. Now what about its values? So if we ignore the effect of air, and the height of the object above Earth's surface is very small in comparison to the radius, means h is very less than r. Means suppose this is our Earth and the object is either on the surface, then h will be 0, and if it is some above the Earth's surface, then this h, the value of h, suppose the object is at this height, so the height h is very negligible in comparison to the radius of Earth. In that case, in these cases, we get that the value of c is 9.8 meter per second square. 9.8 meter per second square. Clear? So now we have got one point, that what is acceleration due to gravity. Acceleration due to gravity is actually it is the acceleration produced in any object due to the gravitational force of Earth acting on it, and this acceleration due to gravity is small g. Its value is 9.8 meter per second square. Okay, so in order to have a more clear concept of this acceleration due to gravity, we are talking some examples. Suppose we have an object at a height h, it is at a height h, and we are releasing this object freely, means u is equal to 0. Suppose any object is released from some height above the Earth's surface, so its initial velocity will be 0. Now what is the effect of this acceleration due to gravity? We are just going to understand it. So there will be acceleration due to gravity, and its value will be g g is equal to 9.8 meter per second square. Okay, but for having learn to make easier calculation, we are just supposing that it is nearly equal to 10 meter per second square. Okay, its value is 10 meter per second square. So what will happen? What will happen? What will be the effect of this acceleration due to gravity? We are just going to understand this effect. Suppose this is here we are plotting, we are observing here time, this is t. When t is equal to 0, here t and this is b, the velocity of the object is here b. So at t is equal to 0, when t is equal to 0, then the velocity of the object is also 0, and after 1 second, when it moves for 1 second, 1 second later, its velocity will be changed by 9.8 meter per second square, or we can say that 10 meter per second square. So its value will be, this will be 10 meter per second square. Means when the time is 1 second, then the velocity is 10 meter per second. After 2 seconds, it will again be increased by 10 meter per second. So value will be 20 meter per second. After 3 seconds, it will be 30 meter per second. After 4 seconds, it will be 50 meter per second. So this is actually the actual meaning of acceleration due to gravity. Means any object, if it is falling freely, its value is continuously increasing 10 meter per second. Clear? If you take its reverse part, then what is going to happen? So suppose we are taking a object here, and it is initially projected with some fixed amount. Suppose its initial velocity u is 50 meter per second. 50 meter per second. So its acceleration due to gravity will be in opposite direction. So in 1 second, each and every 1 second, its velocity is going to decrease by that amount. That is 10 meter per second. So here again we see the time here t is equal to 0. Then the velocity of the object is 50 meter per second. After 1 second, its velocity will be decreased and it will become 40 meter per second. 2 seconds, this is 30 meter per second. Okay, 3 seconds, 20 meter per second. 4 seconds, this is 10 meters per second. After 5, this is 0 meter per second. So here we are observing that whenever any object is in motion under the gravity, its value is continuously increasing or decreasing by an amount, that is 9.8 meter per second, or nearly we say that 10 meter per second. When it is moving upward direction, its velocity is decreasing per second 9.8 meter per second, and when it is moving downwards towards the center of the earth, then its value is increasing. So this is the actual meaning of the gravity and is the actual concept of acceleration in gravity. Now, this motion under gravity is actually a very interesting example of motion, uniformly accelerated motion of the object in a straight line. जब भी कोई ऑब्जेक्ट स्ट्रेट लाइन में मोशन करता है, यूनिफॉर्मली एक्सेलरेटेड मोशन कर रहा है, उस केस का एक पर्टिकुलर एग्जांपल है. So we are going to see the equations of motion under gravity. Its examples are very simple. It is just the same equations as we have derived the equations for the object moving uniformly, going in a uniformly acceleration. That we have seen in previous classes that if any object is there and it is moving It is moving with a uniform acceleration. With a uniform acceleration. Suppose the acceleration is its initial velocity is u, and it is moving with a uniform acceleration a, and it moves up to time t second, and after t second, suppose its initial position is a and the final position is b, and it has, when it is at its final position, its final velocity suppose it becomes v, and during this moment its displacement is there, and the displacement, suppose the displacement is s. Okay, so there are 5 parameters: initial velocity, final velocity, acceleration, time, and displacement. So with the proper experiments, with the proper derivations, we have established the 3 important equations, relations between these 5 parameters, and these 3 parameters are called equations of motion, and it was derived by Newton. So that's why these are called Newton's equations of motion, and that are very beautiful equations. They are, the first one is velocity time relation, and it is given by v is equal to u plus at, and the second equation is displacement time relation, and it is s is equal to ut plus half at square, ut plus half at square, and the third one is, you know very well, the third is v square is equal to u square plus 2as, v square is equal to u square plus 2as. So these are already known equations. These are the equations of motion of an uniformly accelerated object. Clear? So this our actual topic, which is motion under gravity. It is also the example of uniformly accelerated motion. So the equations will be the similar to one, but there will be some changes, some conventions we will use, and some differences will be there. So without any delay, we are going to explain, we are going to derive the equations for equation of motion under gravity. How will we derive? Suppose we are going to remove it. 1 minute. So suppose any object is under the motion under gravity. So there will be 2 cases. Either the object is moving upward direction, or the object is moving downward direction. So in both cases we will use some convention. What will be the convention? See, this is the origin point from where the object is. This is the earth surface. Suppose this is the earth surface. This is the origin. When the object is moving upward direction, then we take positive, and when it is moving downward direction, it will be negative. If the displacement is upward direction, then the displacement will be taken as positive. If the object is moving upward direction, the velocity will be taken as positive. If the displacement is downward toward the earth of the surface, then the displacement will be negative, and also if it is moving to this direction, its velocity will also be negative. Clear? So this is the convention used in case of writing the equation of motion under gravity. When you are moving, you take each and every terms as a positive. When you are moving downward direction, you have to take it as a negative. Clear? So first case first. When the object is moving upward direction, in upward direction, suppose this is the object, suppose we have the object here, and it is moving with velocity u. Okay, and when it is moving upward direction, then acceleration due to gravity will be downward direction, so u will be positive, and G will be negative. Clear? And displacement, suppose after some time, after time T, it is here, and here its velocity is V. So how much displacement will be? H, and this H will be positive. So in order to write the equations of motion, we replace this S by H, this A by minus G. Okay. So what is the equation? The first equation is V is equal to U plus AT. V is equal to U plus AT plus, after in the place of A we will write G, GT. V is equal to U minus G. The second is V S is equal to UT plus half AT square. So here S, in the place of S we write H is equal to UT plus half A, means here half GT square. Clear? And the third one is V square is equal to U square plus 2S. So here it will be U square plus minus 2GH. Clear? So these are the equations of motion. These are the equations of motion in case of the object is moving upward direction. Clear? Similarly, if we take this case 2, this is case 2, when the object is moving downward direction. Suppose there is any object and it is moving downward. So here, suppose its initial velocity is U and U will be negative. And acceleration due to gravity, what is the value of acceleration due to gravity? It is again acting downward direction. So G will also be negative. Displacement will be downward direction. So H will also be negative. Clear? So suppose after some time T, it is here and its velocity is V. Okay. So how can we write the equations of motion of the object in case of object it is falling downward? So right here, the first equation, how can we write? V is equal to U minus V is equal to U plus AT. So V is negative, so minus V is equal to U is also negative, plus AT, so minus GT, and if we arrange it, it will become V is equal to U plus GT. Clear? Second case, what is the second case? S is equal to UT plus half AT square. So here this H is negative, so we are writing minus H is equal to minus UT minus half GT square. So in order to arranging, after arranging it, we are getting H is equal to UT plus half GT square. Clear? And the last one is V square is equal to U square plus 2AS. So V square is equal to U square. So here V is negative, U is negative. So if you are squaring it, it will be positive. Clear? V square is equal to U square plus 2G minus G minus H. Clear? So finally we are getting V square is equal to U square plus 2GH. So this is the equation of motion of the object when it is falling downward direction. Clear? Okay. So I hope you have understood the equations of motion. When it is moving upward direction, take the value of G negative. When it is falling downward, take it as a positive. Clear? So have a remember it. When we are going to solve the problems, we have to think about this, that in which case which equations will be applicable. Clear? Now the third and the last case is there, free falling. Case third. Case third is free falling. Free falling. Free falling of the object. Free falling of the object. So when the object was falling downward, we have already derived the equations, and it is the same case. The object is falling downward, but in previous case we have assumed that the object has some initial velocity u. But in case of free falling means just the object is here and we are releasing it. Okay, means we are not providing any initial velocity to the object. Clear? So its initial velocity will be zero. In case of free falling, the initial velocity will be zero. So how? What will be the equations? So already we have given that v is equal to u plus gt, h is equal to ut plus half gt square, v square is equal to u square plus 2gh. These were the equations when the object has some initial velocity. But in this case, what will happen? There will be no initial velocity. Both the values of v equal to 0. So we will get the equations. We will get the equations for free falling. In the case of free falling, v is equal to gt, h is equal to half gt square. V will be flown away. U will be finished. So v square is equal to 2gh. V square will be 2gh. Clear? Did you get it? Yes. I hope you are getting very well. Clear? And this case is very interesting and it is mostly used here. V square is equal to 2gh. So what will the value of v? V will be under root 2gh. This is a very interesting case. It is mostly used sometimes when we are directly to determine the final velocity of the object. Suppose it is asked that any object is released, it is falling from some given height, h will be given there, s will be given there. Okay, and it will ask that with which velocity it will collide, it will be falling on the object, on the earth's surface. We will directly calculate the velocity of the object on the earth when it is falling from some given height h. And what will be its value? V is equal to under root 2gh. V is equal to under root 2gh. Okay, so now we are coming to a very we are in a situation now. We have the concept of what is acceleration due to gravity and what are the equations of motion under the gravity. And we have discussed in three cases, and the cases are there are three cases: when the object was moving upward direction, when the object was falling downward direction, and the last one is the free falling cases. Very good. So without any delay, now here some important calculations and results are there. They are very easy things and they are directly used. So we are going to discuss these points also. So some important calculations means here we will calculate some points. First is what is maximum height of the object. If any object is moving upward direction, then what will be its maximum height? Second, what will be its time of flight? Okay, time of flight. Okay, and third one will be velocity of object when it is falling on ground. Clear? And this is already just we have discussed this. What is the velocity? V is equal to under root 2gh. इसे तो हमने अभी भी डिस्कस कर रखा है. Okay. Now these points, maximum height and time of flight, we have to discuss. Okay. So maximum height. How can we calculate the maximum height? These are very simple cases. Suppose we have an object and it is moving with velocity u. We have thrown any object with initial velocity u, and it is asked that what will be its maximum height, means how much above the earth's surface it will reach there. Okay. As we have discussed earlier, then object when it is moving upward direction, velocity is decreasing gradually. Per second and 0.8 meter per second velocity decreasing. So for 1 second its velocity will decrease, and a situation will come there that its velocity will be 0, and once its velocity is 0 it will return back. It will return back. फिर से वापस आना होगा, चाहे जितना दूर जाना होगा, लेकिन फिर कभी ना कभी तो वापस आना होगा. So suppose it is its final phase where its velocity, its initial final velocity is 0. So what is its maximum height? We have to calculate what is its maximum height. Suppose this is maximum height. Okay. So what we can use, which equation we can use? So velocity, initial velocity, final velocity, and displacement. Use the third equation. What is the third equation? Third equation gives that v square is equal to u square minus 2gh y minus 2gh. It is the first case. In the first case when the object is moving upward direction. So here, when the object is at E point, its velocity is 0. So write v is equal to 0, u square minus 2gh. What is the value of h? H is equal to u square upon 2g. So this will be the equation of maximum height of any object when it is moving upward direction. Clear? Now time of flight. Time of flight. How can we calculate the time of flight of any object which is moving with some initial velocity? Time of flight. We are going to derive time of flight. Time of flight. Time of flight. So we are taking the same example. We are going to take the same example where any object is moving upward direction with velocity u, and it reaches at the final position at its peak point where its velocity is 0 and displacement is h, maximum height is h, and we have to calculate what is its time of flight. So in order to find the time of flight, there are two methods. First, we can calculate directly. Thing is here. Okay, so today now we have to calculate the maximum height of the object when it is thrown upward direction. So how can we calculate? This is, let's find out the maximum height. Maximum height of the object when it is projected upward direction. So suppose there is the object, there is any object, and this object is thrown upward direction with a velocity u. It is thrown with a velocity u, and after some time it reaches its peak position where its final velocity becomes 0. So how much maximum height? What is the height where the object's final velocity is 0, and from where it will start moving falling, it will start falling downward direction. So that is called maximum height. So how can we calculate? It is very simple. We have the initial velocity of the object, we have the final velocity of the object, displacement is there. So we can use which relation? We can use the third relation, that is v square is equal to u square minus 2gh. Why minus 2gh? Because it is moving upward direction. So what is final velocity? Final velocity v is 0, so put it 0, u square minus 2gh. And from here we are getting the value of maximum height u square by 2g. We are getting the equation of maximum height s is equal to u square by 2g. So this is the equation of maximum height of the object. Now see, what is the time of flight? What is the time of flight of the object? What is the time of flight of the object? Time of flight of the object. Time of flight of the object, t. So what is the time of flight? Means once the object is released upward direction, it will move to the maximum point where its final velocity is 0, and it will start moving falling downwards, and it reaches the earth ground. So suppose this is the point A and this is point B. After B, its final velocity is 0. Now it will start moving downward direction and it returns back. So how much time it had taken A to B and again from B to A? That is called total time of flight. Clear? And it is also defined that the total time expended, total time consumed by the object in the space is called time of flight. So how can we calculate? We can calculate by a direct method where we have its initial velocity. What we have? We have its initial velocity u, and when it is returned back to the same point, so what will be displacement? Displacement will be 0. Displacement will be 0. And we have to find out the time t. We have to find out the time t. So time displacement is given there. So we are using the second equation. What is the second equation? Second equation is h is equal to ut and minus half gt square. So h is 0. H is 0. This is ut minus half gt square. So we can take t as a common. If you are taking t as a common, this will become u minus half gt is equal to 0. So t can never be 0. This t time is never 0. T is cannot be 0. So what will be 0? This will be 0. If this is 0, then we are getting u minus half gt 0. So here from here we are getting t is equal to 2u by g. 2u by g. So this is the equation of time of flight of the object. We have got the value of maximum height. We have got the value of time of flight. So these are two very important conclusions for the object when it is moving upward direction. And one is also there. That is the velocity of the object when it is freely falling from the maximum height h. So its velocity on the ground v is equal to under root 2gh. So this, and one is again there. If any object is projected with velocity u and it is coming back to the same position, so what will be its velocity? Here is velocity v will be u. जिस वेलोसिटी से ऑब्जेक्ट ऊपर की ओर जा रहा है उसी वेलोसिटी से वह अर्थ के सरफेस पे गिरता है. क्लियर? तो these are the some important conclusions and equations in the case of object which is moving upward direction and downward direction. Clear? Now coming to some problems. So once we had the equations of motion of the object under gravity, we can solve various problems. And during solving any problems, we have to just see which equation is to be used. Depending upon various cases, we will use the equations which are required in that particular cases. So these equations which will be more clear when we are going to solve some questions. See, here is the first question. A stone is dropped from a balloon rising upward with a velocity of 16 meters per second. The stone reaches the ground in 4 seconds. Calculate the height of the balloon when stone is dropped. This question is, see, what the question is? This drop is stone is dropped from a balloon rising upward direction with velocity 16 meters. There is a balloon. Suppose there is a balloon. There is a balloon. It is moving upward direction with a velocity u is equal to 16 meter per second. Okay, and suppose this is the earth surface. The stone, any stone is released from here. We are releasing a stone from here, and it reaches to the ground. It reaches to the ground in 4 seconds. 4 seconds. Okay. The stone reaches the ground 4 seconds. Calculate the height of the balloon when the stone is dropped. So we have to find out the height. What is the height of the balloon? Suppose this is the height. This is the height of the balloon from where it is released. Clear? So when it is released, suppose we are releasing the object, the stone here. When it is released, t is equal to 0. At t is equal to 0, what will be its velocity? Its velocity will be the same velocity. What the velocity of the balloon is there? Means its velocity u is equal to 16 meter per second. 16 मीटर पर सेकंड. जब ऑब्जेक्ट को छोड़ा जा रहा है तब इसकी इनिशियल वेलोसिटी है 16 मीटर पर सेकंड. Then it is moving. So when it has initial velocity u is equal to 16 meter per second, so it will move up to some extent. ये कुछ टाइम तक ऊपर जाएगा और उसके बाद फिर नीचे गिरने वाला है. तो टोटल टाइम कितना लग रहा है? How much height is there? Clear? So we can solve it. How can we solve? We have the initial velocity. Initial velocity u is 16 meter per second. Okay. Time t is given there. T is equal to 4 seconds. So how much displacement will be there? Displacement is h is equal to ut. The object is moving upward direction. G is downward direction. So ut minus half gt square. Ut minus half gt square. So this u is 16 into t. How much t? 4 minus half g. You can take the value of g. G value is not given there. So we will use 9.8 into t square. T square means 4 into 4, 16. So this is 2 into 8. This is 64 minus 64 minus this is 78. This is 78. Yes. So reduces, this will be 4, 8 in 8. This is 2. This is 4. This is again 4. This. So 14 point. This is negative. H is equal to minus 14.4 meter. Minus 14.4 meter means its displacement is downward direction. That's why we are getting the negative value. This H is downward direction. Which option is This B is correct. 14.4 meter per meter. Clear? Now there is again a question. A ball is thrown vertically up from the top of 80-meter building with velocity of 30 meter per second. Find the time of flight, maximum height, velocity, and so on. Different questions are there. So we will solve one by one. The first one, we are going to first solve the first problem. Ball is thrown vertically from a top of 80-meter building. So C. Suppose there is a building and its height is 80 meter. Its height is 80 meter. Okay. Building with velocity of 30 meter per second. What is velocity when the object is released? Its velocity u is 30 meter per second. Okay. 30 meter per second. Time of flight. First question is time of flight. Time of flight. तो what will happen? जब भी इस ऑब्जेक्ट को इसके टॉप पॉइंट से भेजा जाएगा, इट विल मूव अप टू सम डिस्टेंस. ये कुछ दूरी तक जाएगा जहाँ इसकी फाइनल वेलोसिटी क्या होगी. सपोज दिस इज A, दिस इज B, एंड फाइनल पोजीशन इज C. सपोज दिस फाइनल पोजीशन इज C, वेयर इस वेलोसिटी इज V is equal to 0. क्लियर? देन इट रिटर्न्स बैक. यहाँ से ये पूरा वापस गिरना शुरू करेगा एंड विल कम हियर. ओके. So, what is the maximum time? So, in order to calculate the time, we need only the initial velocity, displacement is there, and time of flight. Here we want the time of flight. We can use the second equation. We can use the second equation. H is equal to ut minus half gt square. Okay, h is how much? This is minus 80 because the displacement is when the object is moving here. Initial place is here, final position is here, displacement is downward direction, so we are using minus 80 is equal to ut. U means 30 into t minus half. Take the value of g as 10. T square this. Okay, we can solve it. We can get the value of t. This is 5. Now 5t square. Displace here. This will be 5t square minus 30t and minus 80 is equal to 0. Solve it. This will be t square minus 60 minus this 16 is equal to 0. Now do the factor of this. This will be 8 and 2. This will be t minus 8 and t plus 2 is equal to 0. Okay, yes. So t will be minus 2, that is not used. Time can never be negative. Here t will be 8 seconds. So time will be 8 seconds. It is the question. Okay. So the first question has been solved. Now maximum height from the ground. What is the maximum height? First we have to calculate this height. Suppose this height is h. This height is h. Once this height has been calculated, top point तक कहाँ पहुँच रहा है, then we will add and we will get the value of maximum height. So initial velocity is 30 and final velocity is 0. So what will be the displacement? We can calculate the displacement. This v square is equal to u square minus 2gh. V square is equal to 0. Or directly we can use h is equal to u square by 2g. So what is v square? 30 into 30 upon 2 into g. Okay. So we can solve this. This is 90 upon 2. that is 45. That is 45 meter. The value of h is 45 meter. Then the maximum height is the second question. What will be the maximum height? Maximum height h will be 80 meter. This is 80 meter and plus this is small h. This is small h means 45 meter. So we are getting 125 meter. So this is the value of maximum height. This is the second question. Velocity at which the ball will strike the ground. ऑब्जेक्ट किस वेलोसिटी से इसे स्ट्राइक करेगा? तो वी आर टॉकिंग C to A. तो at C maximum height is 125 and velocity here we are going to calculate the velocity v. So we can use the third equation, v square is equal to u square plus 2gh. v square is equal to u square plus 2gh. This is the third case. We use v square is equal to u square plus 2gh. So when your object is falling from C to A, u is 0. Okay. So we get it v square is equal to 0 plus 2gh. How much h is there? 125. 125. So v square is equal to 2 into 10 into 125 like 25. So this is this is 10 into 5 into 25. So this will be 100 into 25. This is v square. So what will be the value of v? Take the root. This will be 10 into 5 is 50 meter. Velocity will be 50 meter per second. 50 meter per second. This is the third question. Velocity and height of the ball from the ground after 5 seconds. Velocity and height of the object of the ball from ground after 5 seconds. 5 सेकेंड के बाद ऑब्जेक्ट की हाइट क्या होगी और ऑब्जेक्ट की वेलोसिटी क्या होगी. Okay. So this is the fourth case. After 5 seconds, the velocity of the object is v is equal to u minus gt. And what is the initial velocity? 30 meter minus g into t. How much t? 5. So this is 30 minus 50 means minus 20 meter per second. Velocity इसका minus 20 meter per second है, means इस 5 seconds में ये it will start moving downward direction. It will start moving downward direction. That's why its velocity is negative. Now what is height at one surface? Earth surface. So what is the displacement after 5 seconds? Then h is equal to ut minus half gt square. So h is 30 into t minus half gt, 10 into 5 into 5. So its value is, this is 150 minus this is 125, means 25 meter. It will be 25 meter above. It will be 25 meter above. Means suppose after time 5 seconds position is, this is C, this is D. It is at D. So it is 25 meter. This is 25 meter. So what will be the height above the earth surface? So height above earth surface, height above earth surface h is equal to 80 plus this 25. means 105 meter. So in this way we solve different types of problems of motion under gravity. Here we have solved two problems in which the first one was having only one calculation, but in this second question we have calculated four questions one by one. So we can solve other questions in the same way. Here we have more questions. One by one we can solve it. So in this motion under gravity, if there is any question, we just read it and think what the condition is there and which type of question, which question is applicable. That equation apply and we can solve different types of problems. One and last question is there. A man drops ball downwards from a roof of tower of height 400 meters. At the same time, another ball is thrown outside a velocity thrown upside. There is a correction. This is upside. Clear? With a velocity of 50 meters per second from the foot of the tower. What is the height from the foot, the tower where the two bars would meet? See this question. This is very easy one. We can solve it. Suppose this is the building. The question is saying that a ball is downward. Any ball is here and it is moving downward with the velocity u is equal to 400. Oh, sorry. A man drops a ball downwards from the roof of a tower at height 400 meters. The height of the tower is 400 meters. Clear? Ball is dropped here means initial velocity is 0. Okay. At the same time another ball. उसी टाइम पर एक दूसरा बॉल ऊपर की ओर भेजा जा रहा है और उसकी वेलोसिटी है 50 मीटर पर सेकंड. 50 मीटर पर सेकंड. Now what is the question? The question is what is the height from the foot of the tower where the two balls would be? अर्थ के सरफेस से कितने हाइट पर दोनों एक साथ मिलने वाले हैं. सपोज दिस इज द हाइट h. मान लेते हैं इस हाइट h पर ये दोनों आकर के मिल रहे हैं. ये ऑब्जेक्ट आ रहा है यहाँ और दिस ऑब्जेक्ट इज मूविंग हियर. बोथ आर मीटिंग एट द सेम हाइट. तो व्हाट इज द टाइम? What is the height of the foot of the tower where the two balls would meet? So suppose how much time after t time this object is coming here after t second. t second में ऑब्जेक्ट यहाँ से यहाँ आ रहा, उतने ही सेकंड में ऑब्जेक्ट यहाँ पहुँच रहा है. क्लियर? तो if it is h, so how much it will be? It will be 400 minus h. It will be 400 minus h. Clear? So we will use the equation. For this object and this object. So use the second equation. Displacement. This is 400 minus h will be h is equal to ut minus plus half that is falling downward. S is equal to ut. U is 0 into t plus half gt square. Or we can write 400 minus h is equal to half gt square. This is question number 1. Now write the equation for this object when it is moving upward direction. How much displacement is h? Displacement is h is equal to ut. What is velocity? Ut means 50 into t minus half gt square. This is equation number 2. Now using these two equations we can find the value of h. So you can find t from here. So adding equation 1 and 2, this is cancel down. This is 400 is equal to 50 into t. That is t is equal to 0, 0. 8 seconds. T is equal to 8 seconds. So we have got the value of T. Once we have got the value of T, we can calculate the value of H. What is the value of H? What is the value of H? You can solve it. We are solving on the next slide. Yes, H is equal to ut minus half gt square. U, what is the value of U? U is 50 meter per second. So this is 50 into T, 8 minus half G into T square. T square means 8 into 8. So this is 400 minus 5. This is 40 into 8 means 400 minus 320. So this is this is 80 meter. 80 meter. At height 80 meter, they will meet each other. Okay, let's go to 80 meter. Clear? So this way we can solve different types of problems of motion under gravity using the equations of motion under gravity depending upon the different conditions. Okay. So everyone, solve more problems. We will meet you in the next video. Bye.